Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So to solve this, I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now, I'm going to rewrite x to the power of 6 here as x to the power of 3 times 2. Now I have this minus x to the power of 3 minus 2 is equal to 0. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 2, that's going to equal x to the power of 3 to the power of 2. Now I have this minus x to the power of 3 minus 2 is equal to 0. Now, I'm going to let x to the power of 3 equal to the variable y. So if I replace y with x to the power of 3, I get y squared minus y minus 2 is equal to 0. So now to solve this, all I have to do is simply rewrite negative y here as negative 2y plus y. Now from here, if I factor out y from y squared minus 2y, I get y times y minus 2. And the greatest common factor of y and negative 2 is just 1. So I have 1 times y minus 2. And now if I factor out y minus 2 from this, I get y minus 2 times y plus 1 is equal to 0. So now this gives me two equations. I have y minus 2 is equal to 0, and I have y plus 1 is equal to 0. So for y minus 2 equals 0, y is obviously equal to 2. And for y plus 1 equals 0, y is equal to negative 1. So now remember how we let x to the power of 3 equal to y. So if x to the power of 3 is equal to y, and we have two solutions of y, we have y equals 2 and y equals negative 1. So I have x to the power of 3 is equal to 2. So to solve this, I'm going to take the cube root on both sides. The cube root of x to the power of 3 is x, and the cube root of 2, that's simply cube root of 2. So one solution of x is the cube root of 2. Now I have x to the power of 3 is equal to negative 1. And to solve this, again, I'm going to be taking the cube root on both sides. So now I have the cube root of x to the power of 3 is equal to the cube root of negative 1. Now again, the cube root of x to the power of 3, that's simply equal to x. And the cube root of negative 1, well, the cube root of a negative number is still going to be a negative number, so the cube root of negative 1 is negative 1. Alright, so in this problem, I have 0.2 to the power of x is equal to 2. So for this problem, I want to find the value of x. So for my solution, first start with 0.2 to the power of x is equal to 2. Now I'm going to take the log on both sides. So I have log 0.2 to the power of x is equal to log 2. And if I have something in the form log a to the power of b, I can actually move this exponent b here to the front. So this can equal b times log a. So in this case, I have log 0.2 to the power of x, and I can move x to the front. So now I have x times log 0.2 is equal to log 2. Now if I divide both sides by log 0.2, these two cancel out, and I get x is equal to log 2 over log 0.2. Now, if you notice here, log 0.2, well, that's the same thing as log of 2 over 10. And if I have something in the form log a over b, this is simply equal to log a minus log b. So in this case, a is 2 and b is 10. So I can rewrite this as x is equal to log 2 over log 2 minus log 10. Now, log 10, as we all know, is simply 1. So I have x is equal to log 2 over log 2 minus 1. Now, log 2, this is equal to 0.3010. So I have 0.3010 over 0.3010 minus 1. And now this is equal to 0.3010 over 0.6990. And finally, if I divide these two, I get that x is equal to, this is actually negative 0.6990. X is equal to negative 0.43. Alright, so in this problem, I have 2 to the power of x plus 4 to the power of x plus 8 to the power of x is equal to 39. So to solve this, I'm going to first rewrite this as 2 to the power of x plus 2 squared to the power of x plus 2 to the power of 3 to the power of x is equal to 39. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So 2 to the power of 2 to the power of x, I can rewrite as 2 to the power of x to the power of 2, and 2 to the power of 3 to the power of x, I can rewrite as 2 to the power of x to the power of 3. Now, I'm going to let 2 to the power of x equal to the variable y. So now I have y plus y squared plus y to the power of 3 is equal to 39. Now, I'm going to subtract 39 on both sides. So these two cancel out, and now I have y to the power of 3 plus y to the power of 2 plus y minus 39 is equal to 0. Now I'm going to rewrite y squared here as negative 3y squared plus 4y squared. So I have this plus y minus 39 is equal to 0. Now, from y to the power of 3 minus 3y squared, I can factor out y squared. So I have y squared times y minus 3. So now I'm going to add 4y squared, and I'm going to rewrite y here as negative 12y plus 13y. So now from here I have y squared times y minus 3 plus, from 4y squared minus 12y, I can factor out 4y. So I have 4y times y minus 3 plus 13 times y minus 3. This is equal to 0. So now if I factor out y minus 3, I get y minus 3 times y squared plus 4y plus 13 is equal to 0. So now this gives me, two equations. I have y minus 3 is equal to 0, meaning y is equal to 3. And I have y squared plus 4y plus 13 equals 0. So to solve this, I'm going to use the quadratic formula, which is negative b, so negative 4 plus or minus the square root of b squared. So 4 squared minus 4 times a, which is 1 times c, which is 13. And if you notice, this is actually going to be 16 minus 52, which is negative 36. And you can't take the square root of a negative number, so this is wrong. And my only solution for y is 3. Now remember how we let 2 to the power of x equal y, meaning 2 to the power of x equals 3. So now to solve this, I'm going to take the log on both sides. And this is the same thing as x times log 2 is equal to log 3, meaning x is equal to log 3 over log 2.